Hello everyone, myself Faz. Today we are going to solve the problem of UPSC 2013 problem from topic Cauchy residue theorem. Here in the question, using Cauchy residue theorem to evaluate the integral is given by I is equal to 0 to pi sin to power 4 theta d theta. The question is based on Cauchy residue theorem. UPSC asked in 2013 for 15 marks. Let's solve the problem. Given integral is this is given by I is equal to 0 to pi sin की power 4 theta sin की power 4 theta d theta. First we have to change the integral limit, taking the given integral half of this is 0 to 2 pi sin की power 4 theta d theta, and we know that z is equal to e to the power of I theta in complex quantities. So we have to here differentiating with respect to theta. This gives dz is equal to e to the power of I theta, and again I theta differentiating with respect to x. This gives I into d theta, and from here putting the value of e to the power I theta, this is z. This is dz is equal to iz into d theta, and from here d theta is equal to dz upon iz, and we can also write z is equal to e to the power I theta. Z is equal to e to the power of I theta is written as cos theta plus of I sin theta. When we have to solve using Cauchy residue theorem, only consider the real part of the given problem. So we have to write here this is e to the power I theta is equal to cos theta plus I sin theta, and further we know that using trigonometry formula, this is given by cos 2 theta is equal to 1 minus of 2 sin square theta, and from here minus of 2 sin square theta is taken to left hand side. This gives 2 sin square theta is equal to 1 minus of cos 2 theta, and from here this is sin square theta is equal to 1 minus of cos 2 theta upon 2, and we have to find the value of sin की power 4 theta d theta. On squaring both the sides, this gives sin की power 4 theta is equal to 1 minus of cos 2 theta का whole square upon 4, and we have to put here this gives I is equal to 1 by of 2. Integral limit is 0 to 2 pi, and in place of sin की power 4 theta we have to put 1 minus of cos 2 theta का whole square upon 4, and from here 1 by 4 and 1 by 2 is sticking to outside. This gives 1 upon 8 and 0 to 2 pi, and we have to expanding 1 minus of cos 2 theta का whole square. This gives 1 plus of cos square 2 theta and minus of 2 cos theta. Here is d theta is also present, cos 2 theta d theta, and further we can also eliminate cos square 2 theta with the help of trigonometry function. This is given by cos 2 theta is equal to 2 cos square theta minus of 1, and here we have to find the value of cos 2 theta, cos square 2 theta. So we have to write here in place of cos 2 theta, we can also put here this is cos 4 theta. We have to change the angle. When we take 2 theta, here is theta. When we take 4 theta, here is 2 theta. So we have to write here 2 cos square 2 theta minus of 1, and we have to put the value of cos square 2 theta. So 1 plus of cos 4 theta minus 1 is taken to left hand side, and this gives 2 cos square 2 theta. And from here we have to find the value of cos square 2 theta. This gives cos square 2 theta is equal to 1 plus of cos 4 theta upon 2. And we have to put here, this gives integral I is equal to 1 upon 8 and integral limit is 0 to 2 pi, and here is 1 plus of, in place of cos square 2 theta we have to put 1 plus of cos 4 theta upon 2 and minus of 2 cos 2 theta, and this is d theta. And further we have to take LCM here. Once again this gives I is equal to 1 upon 8, integral limit is 0 to 2 pi, and taking LCM here, this gives 2 plus of 1 plus of cos 4 theta and minus of 4 cos 2 theta d theta upon, here is 2 and 2 is taken into outside. This gives integral I is equal to 1 upon 8 into 1 upon 2. This gives 1 upon 16. Integral limit is 0 to 2 pi, and from here this is 2 plus 1 is 3, and this is cos 4 theta and minus of 4 cos 2 theta, and here is 2 plus 1 is 3, and so we have to put the value of cos 4 theta and cos 2 theta. From here we know that e power I theta is equal to cos theta plus I sin theta. When we first squaring both the sides, this gives e to the power of 2I theta is equal to cos 2 theta plus of I sin theta, and we have to consider only real part of the given quantity, and we can also z is equal to e to the power I theta is again squaring, this gives again squaring both the sides, this gives e to the power of 4I theta is equal to cos 4 theta plus of I sin 4 theta, and we have to put here, this gives integral I is equal to 1 upon 16, integral limit is 0 to 2 pi, and in place of cos 4 theta we have to put e to the power of 4I theta and minus of 4, in place of cos 2 theta we have to put e to the power of 2I theta, and here is plus of 3 is already present, and this is d theta. Further we have to write, once again we have to also missing, in place of d theta we have to put, this is dz upon iz, so we have to missing here, so I have to write here, and we can write here also, nothing to affect, we can also write once again, we can put integral I is equal to 1 upon 16 and the integral limit is 0 to 2 pi, and in place of e to the power of 4 theta we can write z की power 4 minus of 4, and here is e to the power 2I theta, we can also write 4z square plus of 3 and in place of d theta we have to put dz upon iz, and further once again 2 plus 1 is 3, and further we have to solve, here, this gives I is equal to 1 upon 16I is taken to outside, this is integral limit is 0 to 2 pi, and here is z की power 4 minus of 4z square plus of 3 upon z dz, and we have to here the simple poles are, we have to get simple pole that is z is equal to 0, taking denominator is equal to 0, and z is equal to 0 lies inside the given unit circle, lies inside the unit circle. So we have to find the residue at z is equal to 0. This gives, we have to put here once again, this is fz, when we have to put here once again z is equal to 0. Once again z, we have to put z is equal to 0. This gives residue is residue at z is equal to 0. This gives limit z tends to 0, and this is once again, this is z, and z की power 4 minus of 4z square plus of 3 upon z, and we have to put here, this gives z to z is cancelled out, and here is residue is z is equal to 0 is 3, and we know that by cauchy residue theorem the sum of residue is integral limit I is given by I is 0 to pi, and we can write sin की power 4 theta d theta is equal to, here is 1 upon 16 I is already present, 1 upon 16 I, and we know that the sum of residue 2 pi I, once again sum of residue is given by 2 pi I into sum of residue, here is residue is 3, so we have to write here this is 6 pi I, and further we have to put here this is 1 upon 16 I into 6 pi I, and from here pi is cancelled out, and 2 3 is 6 and 2 8 is 16. This gives integral 0 to pi sin की power 4 theta d theta is equal to 3 pi upon 8, and this is the required solution of the given problem. We have to find here simple pole z is equal to 0 lies inside the unit circle. Further we have to find residue at z is equal to 0. This gives 3, and Cauchy residue theorem, the fz is given by the 2 pi I into sum of residue. Here sum of residue is 3, so we have to put here 3, this gives 6 pi I, and further we have to put in the integral, this gives 0 to pi sin की power 4 theta d theta is equal to 3 pi upon 8. Thank you class, and thank you for watching.